Similarity, boys and girls, means that figures are. Who can tell me what similarity means? If two figures are similar. What?
They look the same.
They look the same. Very good, Deanna. So this figure, if I were to, let me see if I can do this. File, edit, copy. File, edit, where's edit? Edit, paste. And I make a copy of these two things. Whoops. And I drag this. Can I drag this? How do I drag it? Hey, grab it and move it. Okay? Are these two figures similar? Mm-hmm. Yeah, okay. Now, what if I drag this like this? Are these two figures similar?
Yes.
Yes. What makes them similar? What
Same shape.
The sides are proportional. What about the angles, Lena?
They're the same on each.
They're the same, right? So if I were to take this figure and instead of squishing it, instead of just dragging it and expanding the whole thing, are those two figures similar? No, right? Because these angles here, these angles have changed, right? When I squish it or I stretch it, it's kind of like looking in a funhouse mirror. They're no longer similar, okay? So in order for things to be similar, they need to be, you could call it the same size, or not same size, same shape, right? Same shape and different size. Same shape. I guess they could be the same size, but that's not very interesting. Same shape. Let's hide this thing. Different size. Different size. And when you blow something up, when you make it bigger or smaller, that's called a dilation. Okay? Dilation. Okay? So when you make something bigger, you dilate it, right? When you make something smaller, you're also dilating, okay? So say I multiplied everything by 2, that would be called the dilation of scale factor 2. We'll talk more about that in a minute. Okay, the other thing about similarity, sides are proportional. Sides are proportional. We talked about proportions, right? Proportional. And something else about the angles. Angles are congruent. Hello there. Okay, angles are congruent. So that's what similarity is. And then you'll have some questions like, are these things similar? So I'm going to I got to get my notebook back here. So don't look at my notebook. So, let's get a new piece of paper. I'm going to try to draw a trapezoid. Can I draw a trapezoid? What tool? Where's that tool? Where's that tool? This thing. Say where to do this. There's a trapezoid. Ooh, that's good stuff.
Whoa.
Okay? And, I don't know what it is. There it is. Okay? And, I want to see something. That might go by my record. Okay. I'm going to go back. All right. I'm going to copy this.
So you back up?
Back up in a minute.
Don't you talk?
I don't want that. Can I? Oh, well. I'm going to make another trapezoid. Hey. Shush. Here's another. Is this the tool? That's not the tool. That's the tool. I want to make another trapezoid. That kind of looks like this trapezoid. Maybe it's the same trapezoid. Maybe it's not. Okay? Oh, it's supposed to turn into something. Hey!
It's too old.
Why didn't that work?
That was too bad.
Oh.
redo?
Redo.
Where?
Right there, edit.
Go to
Edit.
edit. Yeah.
There you go. One more time.
Okay, there. So I'm gonna try using this tool again. Okay? Let's try to draw this. Uh-oh, it's not.
Oh.
Okay, not bad. Alright. So say I know in this particular trapezoid that this is 8 and this is 12 and this is 10. And I tell you, and this is 10 over here. And I will say given A, B, C, D. Oh, I have the letter, the A, B, C, D. I'm going to call this something. A, B, C, D, and F, G, H, F, G. Let's call this E, F, G, H. Okay? And given A, B, C, D is similar. This symbol right here means similar. It's kind of like congruent, but it's only one of them. Is similar to E, F, G, H. And they will say something like, if find CD. Could you find CD? 6.6. Find CD. And to do that, how do you get 6.6? Oh, the ratio is 2/3. And well, you're pretty smart.
Slow down.
No, but also, so you know that if these are similar, the sides have to be proportional. So 8 is to 12 as CD, which we'll call X, right, is to 10. And then you just cross multiply and you get 80 equals 12X. You could have reduced this to 2/3, which would have been probably better, right? And so X is 80 over 12. Is that 6.6? Is that 6.6? 6 and 2/3?
Yep.
Okay, that's 6 and 2/3 if you reduce it. Okay? So that's one type of problem you'll see. What if they tell you that this angle is 100 degrees over here, okay? And they tell you that these sides are parallel, like this, and like that, okay? What's the measure of angle E? Could you find that?
80.
80, right? Because in similar figures, all the angles have to be congruent. So if this is 100, this is 100. And if these are parallel, these are supplementary. So angle E would have to be 80. Any questions so far? No. Okay. So then they'll have something that looks like this. And hey, no yawning. We're not yawning. Yeah, Stu.
You're gonna be the worst doctor.
So, are these figures similar?
No.
Why not?
No.
Because even though the sides are proportion is 3 to 12 as 2 is to 8, is that true?
Yes.
Yes. What's the ratio of dilation, or what do they call that? The
Dilation, similarity,
By force.
conjecture.
the
Oh.
okay, dilation of is 4. Okay. Are these angles the same?
No.
No. Okay. So no, because the angles are not. Okay. And you'll have other problems that are similar to that. No pun intended. So the trickier problem is when you get something that looks like this, this and then try to, I'm just going to use this tool again and draw a shape that kind of looks like a diamond shape, kind of like this. What will that do? Good enough. Okay? And then I'm going to draw a line going across, a straight line without arrows on the end. Not dotted, I'm going to make that green as well. I'm going to go like this. So they like to give you problems. They and me like to give you problems like this because these could be a little bit tricky. So say I tell you, even though this might not be to scale, that this is 4, that's 5, this is 9, and I call this A, B, C, and I call this D over here, and I give you that triangle ABC is similar to triangle CBD. Triangle CBD. And I tell you to find BD, find BD, and not BD, we already have BD. Find BC, could you, yeah, I can do that. Find, no you don't. Find BC and CD. CD. Okay? And you say, I don't know how to do that. There's no side that matches up with this one. Okay? So what you have to do is you have to look at the similarity statement. Okay? So AB goes with what in this triangle? CB. So I'm going to call CB X over here. So you know that you have to set up proportion. 4 goes with X as the other side I know over here is AC. As AC goes with what? I'm going to call this Y, right? As 5 goes with what? Y, which doesn't work, right? So you can't use that yet. Could I use AB? Let's try to set up another one. How about if I use AB goes with AC, AB goes with AC, right? In this triangle, AB goes with AC as what goes with what in this triangle? AB corresponds to CB, right? As X goes with that doesn't work either. That doesn't work either. I'm trying to get something that has BD. BD. What's BD over here?
BC is 4.
BC is 4. How do you know that?
Because it's to AB.
AB. We better pause. That's where you gotta be kind of smart, kids. Watch. So, which I'm not. BD, okay? BD in this triangle goes with what in this triangle? 9 goes with BC, X, right? As, now I'm going to look for, as X in this triangle, which is CB over here. You understand that? As CB goes with what in this triangle? AB, right? So
Yeah.
oops, as X, sorry. As X goes with 4, okay? And so in this case, you get that X squared equals 36, X equals 6.
Yes, Savannah.
So that's kind of tricky. You understand that?
Oh.
Okay? Sometimes, okay? Hey, a better way to do this, probably, is to redraw the triangles, okay? So what I would do if I were you, Santa, redraw the triangles where this is A, B, C, and this is 4, 5, and X, okay? Then I'm going to draw the other triangle so that it lines up with that triangle, okay? Trying to make it line up. That's not good. Second, make a triangle. Kind of, not really. Where this is, so this is A, B, C. So this would be C, let's hide this. C, hide this.
It's the next one.
Oh, it's this one. C, B, D. See? CBD goes with ABC. So this side, CB, if you look at the picture, is X. See? And BD is 9, and CB is Y. So then using that, then I can set up my proportions maybe more clearly. X is to 9 as, no, 4 is to X as 4 is to X as X is to 9. And once you know that X is 6, then you could find Y, right? X is 6 in both cases. So now I could do 4 is to 6 as 5 is to Y. See where I got that one from? 4 is to 6 as 5 is to Y. And so then I have 4Y equals 30, Y equals 7.5. Okay? So that's tricky. So even though the idea of similarity is pretty easy, sometimes it can be hard to set up the proportions. All right. So if I want to dilate this by a scale factor 2, all I have to do is multiply all the coordinates by 2. So this, which was 3, 0, becomes what? So this becomes 6, 0, right? And this 6, 0. And this point over here becomes what? 2, 2, over 2, and up 2, okay? So that point's 2, 2. And this point becomes what? Negative 4, and up 2, okay? Negative 4, 2. And this point over here becomes negative 2, negative 2. So maybe this point right here, that's not a very good picture. It's somewhere like right over here. So that's the next point, negative 2, negative 2. And then if I connect all those, okay, using my straight line tool in a different color, yellow, okay, I should get a figure, what? Pretty close. There, there, and there. And I should have gotten a figure. It's not a, you can, it should be the same size, same shape, just a different size. Okay? So that's what it means to dilate something by a scale factor. Okay? Last one, and and then on your conjecture sheet, it does say, what does it say on that? C92. It says if one polygon is the image of another polygon under a dilation, then the polygons are similar. That means if I can multiply all the coordinates by a number and get the other coordinates, then those figures are similar. And then I'm going to give you one more example, and then we're going to be done for the day. So, say I have something that looks like this, and try straight line, okay? Line, 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 like this, okay? They like to give you, the evil math people like to give you problems like this too. And I'll tell you that this is 6, and this is 5, and this is 3, and this is 4, and this is X, and this is Y. And They won't tell you, so these things can look different ways, okay? So sometimes what they'll tell you is that this angle, or they'll say that these things are parallel, okay? Then what could I say to solve for x and y? Who can give me an equation? If these things are parallel, and I say find x and y, who can give me a proportion to find x and y? If these are parallel,
3 is to x and 5 is to y.
okay? If these are parallel, then this angle is congruent to this angle, right? Which means that this side goes with which side? 5 goes with what? Y, right? So in that case, you can say that 5 is to y as 4 is to 6, right? As 3 is to x, right? So you could use that proportion to solve.
How do you cross multiply that?
Okay, well, you just do one piece at a time, right? First you find y, and then you'll use this set of equations to find x, right? Okay? Can you do that? But you have to be careful, because sometimes they'll tell you this is parallel, which means that this side is the corresponding side with this side. But sometimes they won't tell you that those things are parallel. So if I were to erase these, this and this, and I don't know that these are parallel, okay? And all they give you, say in this case, say they tell you that this angle right here, this is that, is congruent to this angle right there. Now what do I know?
5, wait.
And you know that this, what's got to be true about this and this? They have to be congruent. Therefore, what has to be true about this and this? That this one, so are these figures similar?
Yes.
Yes. So if you had it looking like this, now my ratio changes. 4 is, whoops, what is that? Okay. 4 is to 6 as, 4 is to 6 as what?
5 is to x.
As 5 is to x. Do you understand how that's different? Now if they give you that these are congruent like this, then this goes with this, as this goes with this, as 3 goes with y, okay? So it depends on what's given in the picture, depending on how you solve that proportion, okay? And that is all she wrote, the end.